Okay, here we are, our objective. I realize you might have to watch this video and then watch it again to see the answers, but it's important that you somehow have a way to check this work. So here we go, our objective. You will discover with a partner how the graph of a quadratic is affected by different variables in different forms. You will learn what the value of C in standard form represents in a graph. You will learn that the solutions in factored form, what they mean in the graph. You will learn the value of A in both standard and vertex form and how it changes the graph. You will learn how the value of H and K represented in the graph in vertex form. So in vertex form, how H and K change the graph. So this is about how I feel today. It's crazy trying to figure out how this is going to work as we all come back in and the snow and everything else. So it's a little bit, but we're going to get there. So warm up. How do you see the -2? The -2 is the slope. It's down 2 into the right 1. This graph, of course, doesn't look like it's down 2 into the right 1 because you'll notice that the scale is different, right? We've got 1 through 4 and 2 in the y-axis is counting by 2s. So it looks a little different, but don't be fooled that the slope is going down 2 and over 1. How do I see the +1 or the +8? It is in the y-intercept. In other words, the y-intercept is when x equals 0. So here it's asking for when we see the x-intercept, which is 4. We can see it on the graph, but we also can see it when we solve for x when y is 0. So if y is 0, then we put that equation in and we solve it and we see that y equals 4. So same thing, we can find the x-intercept by letting y equal 0 and the y-intercept by letting x equal 0. Write down some questions you might have. Some things I thought you might want to know is, does a quadratic function always point up? And the answer is no, it does not. Does it also can point down? And you're going to learn that. As you do this Desmos slides. Does it ever point sideways? And the answer is no. And the reason why is because it would not be a function. We've already talked about how a function behaves. And if you did the vertical line test and it was on a sideways sort of U-shaped graph, and it wouldn't be a function. Is it always symmetric? And the answer is yes. I don't know if that's a question that you would have had, but any other questions you would have had, I hope that we get those addressed in this video or this slideshow. Did you actually take notes? If you didn't, please do. Write down this graph so that you can use this all the time. The axis of symmetry, what it is, where the vertex is. You can make yourself a couple different if you want, because remember this would also be, well, this one, something like this, would also be a nice graph, and you could do both of them. There's the vertex, and same axis of symmetry and x-axis. Okay. I've put some solutions here. My x-intercepts are just where it crosses. I can also take these two things and solve. So I can say x plus 3 equals 0, x plus 3 equals 0. I'm just going to do one of them. X plus 3, I don't have a good writing tool right now, equals 0. So then x equals -3. When I solve that equation, x equals -3, which is where the intercepts come from. So if you have the graph, you can look at the graph. Otherwise, you're solving the factored forms with the zero product property and setting each of those equal to 0 as we started to do, as we've already done, really. The y-intercept, I'm noticing that the y-intercept here is 3. I'm also starting to notice where I might see that 3, just like we did in linear. The vertex is where it hits right here. I can see on the graph that it's at -2, -1. Eventually, I'm going to have to get to a place that I can figure out how I do that, and you will have already done that by the time that you did this, watch this video. The axis of symmetry will always be right down the middle. It'll always be y equals whatever the x-intercept, whatever the x term of the vertex is. Okay, next one. This one I've actually shown my work. In order to find the vertex, I go halfway between the 1 and the 4 because those are my x-intercepts, which is 2.5. And then I take my 2.5 and I plug it into the standard form, right? I plug it right there. I substitute into the standard form, 2.5. I actually do get out my calculator and get that it equals negative 2.25. So then my vertex here is negative 2.25. So I find it algebraically. Okay. Notice up here, I know I can kind of see that it's between the 1 and the 3, and kind of maybe I can just figure this out. But if these were more difficult numbers, you would find the difference between them, right? 4 minus 1. So there's 3 units between the two intercepts. I divide that distance by 2, and I get this number, and then I would have to add that to one of them, right? Or subtract in order to find that. So I just have to add the 1.5, right? Really just make a picture if you're struggling with how you find the axis of symmetry or the x coordinate of the vertex. Okay, and then of course the axis of symmetry we said will always be x equals whatever the x-intercept of the vertex is. Next problem. Notice this one's symmetric around the y-axis. The function looks a little different. That might give you a hint as to what's to come. Next problem. Notice this is not a trinomial, it's a binomial, so all we could do is factor out the GCF. But other than that, we did it exactly the same. We found our y-intercepts by setting each of those terms equal to 0, x equals 0. If we did this algebraically, if we weren't looking at the graph, or if the graph was not perfect or we couldn't read it, and x minus 5 equals 0. So then we got our two x-intercepts of 1 and 5. I had to do a little bit of work in order to find the vertex, which was 2.5 and 6.25. I had to plug it in like we did before. And then this problem is exactly the same numbers, it's just upside down. So notice this is not standard form. If it was, it would have been negative x squared. Might be a little bit more clear if it was written in standard form, plus 5x. What's different between this equation and the one before it? And why you came up with the same numbers as far as the vertex goes, except for positive y value. So what did you notice when you looked at the last 5 slides? I'm hoping that you noticed that you could find the x-intercept in factored form and the y-intercept in standard form. I'm hoping that you could find those algebraically, also looking at the graph, but algebraically you should be able to find them looking at the factored form and the standard form. I noted that the axis of symmetry is the x coordinate of the vertex. So it's always x equals whatever the x coordinate is. And I noticed I had to do a little bit of work in order to find the y coordinate. I had to plug it into the standard form of the equation. So it took me a little bit of time. You might have noticed other things. I hope you did. So this slide, I wanted you to play around with it a little bit. It says a parabola is a graph of a quadratic function. Y equals x squared, for example, we use both the quadratic and parabola to refer to the graph of a function having its highest power of 2. A quadratic function has a vertex and an axis of symmetry. Click on the lines 4 and 5 to see each. So there is our vertex. Here is our axis of symmetry, right there in green. Notice if I move it, so our axis of symmetry in this case, as we said, is x equals whatever the x coordinate is. I want to label that. That is my vertex. Next slide. What is the vertex? 0, 0. What is the axis of symmetry? X equals 0. So on this slide back here, you could have seen that it was 0, 0 and use this slide to answer this slide. Y equals x squared is the parent graph of a quadratic. It is the most simple quadratic that we can graph. We will often refer to the parent function as y equals x squared. We can graph this function by hand using the relationship of squaring each x value and get a corresponding value. In other words, the point 0, 0 on the point 0, 0 is on the graph, since if x is 0, y has to be 0. The point 24 is on the graph because if x is 2, that squared is 4, so it's this point, and so forth. So you could plug these in and you would graph it by hand. Okay. This next slide is talking about the k. So that now we're getting into what does the k do? The k is when you add something to just the squared function, just the square, x squared. So as I move k, I notice what's happening. I notice that the parabola is not changing shape. It's just moving up and down. Okay, now it says click on this point. What is it? What is that point? We can label it. Let's look at it. So that point is exactly the same as our k value. So as our k value changes, so does our vertex. And our k value is exactly the same as our vertex. So when my k value is, well, let's go to 0. When our k value is 0, so is our vertex. When our k value is 2, so is our vertex, the y-coordinate of our vertex. Okay, so given that, what that is, it moves it up and down vertically. Therefore, if it moves it, if the k value is -2, then the vertex will be at 0, -2. If the k value is at +5, then the vertex will be at 0, +5. In my own words, and your words do not have to be the same as mine, I said the k value moves the function up and down exactly the same value as k, only when the function is in the form y equals x squared plus k, which is not standard form, right? Because there's no bx here. So don't be confused in thinking that that's the same as the c value in standard form. It's not. This is not standard form. Okay. Now we're going to look at the h value. So the h value in this particular function, notice that this is a -h, but h is positive. So whatever happens to h, what direction does it move it? So as I'm down here at -6.5, my graph is way over at -6.5. I can label my axis of symmetry, and I can label my vertex and see that the vertex, as I move it from left to right, the value of h will be exactly the same as the x value of the vertex. But remember, h is a it's minus h. H is being subtracted. So when you just got to keep that in mind, h is, so let's keep that in mind. So the next one says, given the equation y equals x minus h, the quantity squared, the value of h moves the graph of the parabola horizontally. The vertex of the quadratic in this particular case is going to be 2, 0. Even though that's a negative, remember h is not the negative sign. H is just the value that's being subtracted. So on the second one, because it's a +5, it's going to have to be a negative, since minus a -5 is a +5. So you just have to be very careful that you understand that in this type of equation, the h is just the value, but it will be subtracted. Okay, so horizontal shifts in your version, I'm going to ask you to describe in your own language, in your own words, what h does. How does h shift? And h just shifts it from left to right, and you might want to, and I hope you said something about the fact that h is negative. So the shift happens in the opposite direction of our intuition, and that is exactly what happens. Because it's negative, it goes in the opposite direction. It gets a little confusing, so you're just going to have to keep track of what you're doing. On this particular slide, I wanted you to just kind of play with the h's. So h's are moving from left to right. K's are moving up and down. What about when, and notice this one's labeled. So when they were both at 0, 0, the parent function. So when I had them both at 0, 0, or the parent function, or equal to the parent function, it's right there. But as I move them, I see that they can both move, right? So what happens to the vertexes? I notice that whatever the h is, that's my x value of my vertex. Whatever the y is, that's my y value of my vertex. Excuse me, whatever the k is, that's my y value. So the h value of 4.8 is the same as our h value, or x value in our vertex. Our k value of negative 3.5 is our y value in our vertex. Describe in words how the vertex is related to the h value. Actually, this is going to be changed. When you read it, it's going to say, describe in your own words what the axis of symmetry is. And I've written the axis of symmetry will always be what x equals. The x value in the vertex, because quadratics are symmetric from the vertex, but you can describe in your own words what this axis of symmetry is and how you'll find it in your own words. Give the vertex and the axis of symmetry on several slides. So I know that it will be 3 and 7, and the axis of symmetry will always be the same as the x value. The next one, negative 2, 2, x equals negative 2, 1/7 and negative 1, negative 2, 0 and negative 2, 0, 7, and x equals 0. That one's a little different, right? Wait, did I miss one that was, oh, this one's a little different too. So on this slide, notice there's a 0. There is no plus here. There's no value for k. So the y value will be 0 in the vertex, and there's no value for h here. So the x value will be 0. And then the last thing we want to notice is what happens when we change the a value. So that as we change the a value, at some point it flips. I hope that you played with this enough to figure out when it flips. All of these things. What actually happens when a is 0? I don't think I wrote that down in mine, but when a is positive, the parabola is facing upward. When a is negative, it's facing downward. I notice as I get into fractions or things less than 1, it's getting wider and wider and wider. And then as I get into a number where the value of a is greater than 1. So here at 1, it is the parent function, but as it gets greater than 1, it gets more narrow and more narrow. So as a goes up higher, it gets more narrow, and as a is between 1 and 0, it's wider than the parent graph. At a equals 0, it's a line. Well, think about that. That would mean if a was 0, the number in front of the x squared was 0, that means it's not a quadratic, right? It's a linear function. Okay. Now we're going to go through and just click on what all of these things mean. So relatively quickly, we're going to get to the point, and I know that it's going to take you some time as we start this, so do take your time. Check each problem that you had as you go through this video. Number 1, that graph will be up. Number 2, that graph will be down because it's a negative 2. The a value is a negative 2. Number 3 says the graph of 3 times that is going to be more narrow than the graph without the 3 out in front. So I'm looking at the a values. This is all about the a values. And number 4, the a value is less than 1 because it's 1/3, so it's going to be more wide. So let's keep practicing looking at those a values. Number 1, oh, this is exactly the same one. Just giving you a chance to check it. So looking at how a, h, and k all interact, you can play with this graph. You can see how h is if I change my a value, if I change my h value and my k value. I could label and show you the the axis of symmetry. Okay, name the characteristics. This is the part that will take you some time, and I do want you to go through each one of these slides very slowly, hopefully with your partner. Go back and check these. give the four characteristics of the function. So we're going to, on each one of these, the vertex is going to be the h and the k. So the vertex in this case is going to be a -1 because this is positive, -1, and there is no k, so it's a 0. It's going to be facing downward because a is negative, and it's going to be wider because the a value is less than 1. Okay, x equals -1, and the -1 means that it's going to be the same value as our x coordinate in our vertex. Again, our h and our k values, it goes up because the a is positive, it's narrow because the a is greater than 1, and the axis of symmetry is x equals -2 because it's the same as the h value. I'm just going to go through these a little slowly. You please do stop the video and check your work. I'm on slide 37. Make sure you're on the same slide as you're writing down answers. Notice this is our first normal. It opens up normal because there is no a value. So it's like a +1. This one has no h or k value. So this is like the parent graph, only it's down and more narrow. Explain in your words why this form, where you see it, ax minus h squared plus k, is always called the vertex form. Why do you think that we call it the vertex form? I said because the h and the k in the form are actually the vertex, so it's very helpful. We don't always have it in the vertex form. We have to convert it to the vertex form. Then you have 4 exit tickets, which you're going to do on your own. So I want to know, did we achieve our objective? What does the value of c in the standard form tell you when you're graphing it? What do the solutions mean? How does the a value affect it? And notice the a value is both in standard and vertex form. And then the last one is, how do the h and the k affect the graph, and where do we see it in the graph? The next things you'll have is a big idea is 8.4. So fantastic job.